Okay, so this is our project 3.2.5 Artificial Intelligence Rock, Paper, Scissors Simulation Project, and I worked with Francesca on this. So this project is about using artificial intelligence to analyze patterns in rock, paper, scissors. Even though the game seems random, we wanted to see if data and strategy could help predict moves and increase our chances of winning. So for our social contract, we basically just created that in order to work effectively together without any problems. We basically just said in it that we wanted to listen to each other's ideas respectfully, golden rule, and do your work. So, and then on the right, we have our contact information in case there are any questions or concerns. So our main goals were to collect rock, paper, scissors data, apply coding fundamentals, and create a program that could predict the best move to win. And we were focused on using iteration and logic to make our AI smarter. Our driving question was, how can we create an AI program that predicts and beats an opponent using their past moves? And this question basically guided all of our planning and coding decisions. So our task was basically to design an AI program that remembers previous moves and then uses that data to choose the best next move. So this was to predict patterns in what looks like a random game. In our planning, we decided to use variables, strings, and integers to store move data. We also planned to use if, elif, else statements to predict the opponent's move and play the best move that beats it. So on slide 8, we basically show the data that we collected during the trial, where we went to everybody in the room and we played 3 games. We marked down who won, we marked down what they played, and then that was the data that we used to actually make our AI to tell us what the best next move would be. Slide 9 talks about the AI that we actually used. We used Grok to help us create our actual program and give us the next best move. We also used ChatGPT to do part of that, and then we used ChatGPT to add images into our presentation. So our decision matrix, we compared 2 ideas and multiple parts of the ideas, and we basically counted what scored better, which in this case we decided on idea 2 just because obviously we're supposed to actually use the data that we collect. So the other idea didn't use that data, so we picked idea 2. So slide 11 shows our flow chart, which is, it shows how our program works, like step by step. It checks if there's past data, analyzes move patterns, predicts the next move, and then chooses the move that beats the prediction. And obviously it's a visual chart, so you can see it step by step. So our Gantt chart shows how we managed our time across the 4 days that we worked on the project. We split it into planning, coding, evaluation, and finalizing in order to stay organized and productive. So next we have our pseudocode, which explains the logic behind our program in a simplified way. It shows how we store opponent moves, count patterns, and use functions to predict and counter future moves. The next slide shows my code that I did. The next slide also shows that again. And then the next 2 slides show Francesca's code. So our next slide is our debug slide. During debugging, we found input and keyword errors in the code, and we fixed these by adjusting print statements and replacing invalid functions with manual loops. And then slide 20 is our evaluation, which the feedback was mostly positive. There was a few improvements suggested, but otherwise it was all good. And that is everything. Thank you for watching our presentation. Again, if there are any questions or concerns, our email is on the first slide, so